Okay, well, the sky this month. It's interesting that there's going to be a certain amount of overlap between what I have to say and what Richard just said. So some highlights, of course, is the planets, and then we're going to talk a little bit about celestial longitudes. I wonder why. Okay, so just looking at the month ahead, October the 9th. So that's just that's tomorrow at 7:20 p.m. If you look to the southwest, you will see very low in the sky Venus and the moon. Now, just to give you an idea of how low in the sky, there's your fist held at arm's length. So that represents roughly 10 degrees. So if you have a good southwest horizon, it doesn't have to be that low. I was quite surprised. We've got little mountains outside our house, but we can see down to 2 degrees or so. Then you'll be able to see the moon and Venus basically in one very small region of the sky. So that's tomorrow at 7:20 p.m. Now, October the 14th at 8:30, if you look straight south, then you'll see Jupiter, Saturn, and the moon, and they'll be in a nice little triangle. And actually the moon will not be a full moon as it looks like in this picture, but it'll be kind of about 2/3 illuminated. So that will be an interesting kind of, not exactly conjunction, but pattern. You will also, one of the interesting things is that Jupiter and Saturn are in Capricornus at this time, which is one of the constellations. So as you look at this, you might think constellation, what constellation? Well, there are stars here and here and here and here, but Capricornus is a very faint constellation. It's difficult to see. And yet we know it's famous. We all heard of the Tropic of Capricorn, and what's that got to do with Capricornus? Well, it turns out that this faint little constellation was where the sun was during the winter solstice about 3,000 years ago. Now, I don't know exactly when the Tropic of Capricorn was named, but it's been quite a while since the winter solstice occurred when the sun was in this constellation. If we were to give it its correct name today, we'd call it the Tropic of Sagitta. Sagittarius is the constellation that the sun is currently in when it reaches its lowest point in the sky, or most southerly point in the sky. So October the 25th at 7 a.m. is a very sane time to be up. If you look to the east, then there's Mercury, and this is something that Richard Corbett pointed out in his great article this last Friday. And again, it's fairly low in the sky, so you have to have a pretty good eastern horizon in order to catch Mercury. Mercury is always a challenge. It's one of those things you just go out with your binoculars or your scope just to see if you can find it and catch it before the sun comes up and it disappears. So that's October the 25th at 7 a.m. November the 3rd at 7:20 a.m. You're going to get this interesting conjunction of Mercury and the moon. And there's the star speak off to the side. This is in the southeast. It is, again, fairly low in the sky. So that would be November the 3rd. By the way, this will all be posted on YouTube, so you don't need to take any notes or anything. You just go back and look at it on YouTube. And then November the 7th, there's a real challenge. It's another one. Sorry, this is the moon and Venus are going to be very close together in the southwest. Again, pretty low in the sky. And that's November the 7th at 5:20 p.m. So just if you don't get out there too late, or Venus will have gone down. And then November the 10th, this is where the real challenge is. This is at 6:35 a.m. And that's Mercury. and that's Mars. So these two planets will be that close together. But there is my fist. It goes off the chart here. So we're down to about 2.5 degrees above the horizon. So it'll be quite the challenge to see. But if you can, get Mercury and Mars maybe in the same binocular view, that would be early on November the 10th at 6:35 a.m. Now, I'd like to talk a little bit about celestial coordinates. Of course, places on the Earth have a latitude and longitude, and so a similar grid is fixed to the stars, it should say to the stars. But it's more or less fixed. It actually drifts a little bit from year to year, so much so that every 50 years, astronomers update the locations of stars because it's drifted enough out about, I think it's about 2/3 of a degree out because of the what's known as the precession of the equinoxes. Now, latitude, the actual numerical value of the latitude is real, and that's what the Maoris discovered. You know, they couldn't tell where they were in a longitude, but they knew that a star goes right over top of a particular island, whereas longitude is arbitrary. And I'll just take a look at that. Here's a time exposure photograph looking north. And you can see the stars appearing to go around the center. And Polaris is that little blob that's slightly off of center. A dead center is the North Celestial Pole. So that dead center is 49 degrees above the horizon for us because we're at roughly a latitude of 49 degrees. Now, if you take a circle that just skims the horizon and goes all around concentric with the center of that circle, then all of the stars that are on that circle are 49 degrees from the center, 49 degrees from, let's just say, Polaris. So if we called the dead center a celestial latitude of 90 degrees, then any star on that circle has got to have a celestial latitude of 41 degrees, which is actually called the declination, but it just means the same thing as celestial latitude. The celestial longitude is different. It's the same as the Earth. It rotates with the stars, and the prime meridian is arbitrarily defined to be where the sun crosses the equator in the March equinox. Where is that among the stars? Where actually is the prime meridian for celestial longitude? Well, it turns out if you go out tonight at 11:59, in other words, midnight, October the 8th, okay, and you face south, then if you imagine a line going straight up from due south and straight overhead, when a star crosses crosses that line, it's known as crossing the meridian. And it turns out that 0 degrees will cross that meridian at 11:59 p.m. tonight. So that is where the 0 degrees celestial longitude is. Now you might say, wow, does that all happen all the time? And the answer is no, it's because it happens to be October the 8th that's what happens. Roughly, it's going to be pretty close to that tomorrow night, and it was pretty close to that last night. The reality is that we're roughly 1/2 month past the fall equinox. That's the critical thing. We're a half a month past, and a half a month is equivalent to 1 hour of star motion, and 11:59 p.m. is 1 hour before actual midnight because of daylight saving time. So in other words, our 11:59 really is really 10:59, and so at midnight the actual 0 degrees will have passed, will have gone 1 hour past the meridian. But because of daylight saving time, it just happens to fall on that meridian as it stretches from the south, pointing south to directly overhead. So of course, that only works at this time of year. As you get farther and farther away from the September equinox, then the 0 degrees will cross the meridian at an earlier time. Okay, so that's our 0 degrees. Now let's look at it. Oh my goodness, there is the great square of Pegasus. And notice it, almost parallels one side of the great square. Off to this side, this is where you can see the Andromeda constellation takes off. So you can look at the great square of Pegasus and know that roughly starting, heading from here up, don't worry about the south here, but a line that goes from here up to Polaris, that basically represents 0 degrees, the prime meridian. It's also, so we can say Pegasus is on the celestial prime meridian. It's also known as 0 hours. Okay, what about if we look east at the same time, then this would be the 90-degree longitude. Again, it goes from directly east up to Polaris. But that's only helpful at this instant. But what stars are nearby? Well, by the way, that's called 6 hours. There's Capella, bright star, and this is the constellation of Auriga. So notice that the 90-degree longitude, or the 6th hour of right ascension, just skims past Auriga, and it also goes right through, or pretty close to right through, Betelgeuse in Orion. So in the winter, when you see Betelgeuse, draw a line from that up past Auriga and up to the pole star, you know that you're looking at 90 degrees longitude, or the 6th hour longitude, or right ascension. So 6 hours goes through Betelgeuse and one side of Auriga. What I want you to be able to do is know these facts, so that sometime when you actually find out what the right ascension of a star is, you could say, that's roughly in a certain location, just by knowing these benchmarks. So if we look north, then this is 180 degrees, or the 12 hours of right ascension. And look, there's the Big Dipper. So just through that bottom corner, of course, that specific corner, it's not going to be the bottom all the time, but that specific corner just skims past that to the Polaris. That's 180 degrees. So 180 degrees or 12 hours joins the Big Dipper to Polaris. So, and there's another benchmark of longitude as you go around. See, it's easy to tell latitude because you can just sort of estimate from the angle from the North Pole. But with the longitude, you need these benchmark stars in order to get an idea of where these meridians are. Okay, hang on, let's just go to the next one, which is, if we look west, this is the 270 degrees of longitude, or 18 hours. It's right next to the summer triangle. But it doesn't go through a nice fancy star. It's a little bit off to one side. This is Vega. But it gives you some idea that basically that's roughly where the 18 hours goes. So in summary then, celestial longitude, or technically right ascension, arcs from Polaris to Pegasus, that's at 0 hours, to Auriga and Betelgeuse in 6 hours, the Big Dipper, 12 hours, near Vega at 18 hours. And of course, by the time you get to 24 hours, you're back to Pegasus again. So as I mentioned earlier, you will know you've got it when you can estimate from a star's coordinates roughly where it is in the sky without looking.